Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 97. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is a fusion system with benzene and cyclobutane. You are having 2 phenyl in anti-position. Then you are having anhydride. You are heating it. They ask you to find the product. The products are fused system with new anhydride. Whether the hydrogens are syn or hydrogens are trans, or phenyls are syn to each other or trans to each other, as well as phenyl and hydrogens are syn to each other, trans to each other. So basically the stereochemistry of fusion here. So from the reactant to product you might guess definitely the ring fusion is occur, and the question of stereochemistry also there. The answer is A. Let us see how. The starting metal is fused ring system. Phenyl and cyclobutyl is there. Phenyl is handy to each other. The cyclobutyl ring is very strained one, so it try to open. You are using thermal condition. So 4 and pi electrons are involved. So 4 and thermal means it's a con rotatory or con rotation. So the ring is open there. So you have double bond outside the benzene. Then you are using anhydride. So what really happens is 4 plus 2 cycle addition will be there. So double bonds are fused. You have benzene ring re-established. So aromaticity established and the new ring is formed. Here 4 plus 2 cycle addition is happening. What happened to stereochemistry? The stereochemistry here is syn 1 because cycle addition is the syn 1, so hydrogens are syn to each other. And what happened to phenyl? Because phenyl and hydrogens are trans, because the attack will be always on less crowded side, so it's against the phenyl. Phenyl will be on top, mean you have hydrogen below. It can be vice versa too. So the product is clearly A. Here you have to learn 2 important things. One is 4 and pi electron in thermal condition. Second thing is 4 plus 2 cycle addition stereochemistry. 4 plus 2 cycle addition is a concerted product. Always go up less hindered side, as well as the addition is a syn addition there. Then the question number 4. The starting metal is alkene which is attached with isopropyl, and you have methyl alcohol on the side chain. You are using the reagent as titanium isopropoxide and diethyl tartrate in the plus form, and butyl peroxide and dichloroform and low temperature. They ask you to find the product. The products can be on 4 types. Whether the epoxidation is occur above or occur below, or the formed product can be cis to each other or trans to each other. Since the cyclopropyl ring is formed, the cis trans become valid here. Cyclic ring have above and below plane. So from the titanium as well as DET, you might guess the naming reaction is involved, and epoxide selectivity is the real question here. The answer is D. Let us see how. The starting metal you have alcohol which is on right side. Basically it's a sharp plus asymmetric epoxidation. What really happens is whole reaction is dictated by CH2OH, which should be on lower right. So if the molecule given in the twisted way, it will be on reverse. So you have to write OH on the right side here. Then you have isopropyl alcohol. The OH dictates the stereochemistry along with the diethyl tartrate. So what really happens is OH right side and plus DET you have below the epoxide formation. So the whole reaction looks simple once you know the logic. So OH on right side and plus DET, the epoxide below the plane. Here you have to learn only one important thing, that is sharp plus asymmetric epoxidation. In this sharp plus asymmetric epoxidation you have to always watch for OH position, which should be redrawn to the nice standard form, because the position of CH2OH and DET decide the epoxide selectivity. Then the question number 3. The starting metal you have benzene ring. In meta position you have ketone and ester. You are using diol there. Then you are using another reagent as diol, which is in the 1/3 position. Then you are using methyl magnesium bromide, which is in excess form. Then hydrolysis. They ask you to find the product. Where the methylation occurs is the question here. The methylation can be an ketone or the ester or just on both sides, or simply the elimination of ETO in the ester. So the question is really about where is the reaction center and what the diol is really doing here. The answer is B. Let us see how. The starting metal you have ketone and ester, you are using diol. Diol is a very good protecting agent for ketone. Basically it protects the carbonyl from any chemical reaction. So it is a protecting agent. So carbonyl is protected there. So you have 6-member ring formation, very stable protection. Then you are using methyl magnesium bromide. Methyl magnesium bromide attacks the carbonyl in the ester. So you have ETO elimination. So ETO leaves, methyl just adds there. So again the ketone formation. So what really do? The methyl is in excess, so it can again add. So 2 methyl groups are added there. Again you have OMGBr. Then the next step you are using hydrolysis. During the hydrolysis, OH formation occur as well as deproduction of diol will be there. So here you have to learn 2 important things. One is 1,3-diol product the ketone. So normally it prevents the ketone from involving in the reaction, but carbonyl in the ester not disturbed in the reaction. Second thing is excess of methyl magnesium bromide. What really happen if you use excess? It will continuously attack until the saturation occurs. Then the question number 4, the starting metal is cyanide compound because it contains C triple bond N and O, the NO in the halide form. Then you are using transalkene, then you are heating. The next step you are using nickel hydrogen, which is the reduction step, then you are using hydrolysis. They ask you to find the product. The products can be imine or ketone, whether the alkyl groups are syn to each other or trans to each other or simple amine. The products can be amine or ketone or imine. So amine, imine and ketone. As well as the methyl groups are syn to each other or anti to each other. So if you compare reactant to product, there is a special reaction involved here, and intermediate is the interesting question. The answer is B. Let us see how. The starting metal your charged system, it can be written as 1,3 dipolar system. If you write 1,3 as dipolar system, you can have 1,3 dipolar addition. 1,3 dipolar addition is a concerted process. The stereochemistry of all the reactants will be preserved. So the trans form retained as anti there. Then you have NO and you have hydro ring which has NO. Here NO rings are weak because it's a more polarized bond. So if you use reducing agent NH breaks, you have alcohol and imine there. You are using hydrolysis. So what really happened to hydrolysis? The imine become ketone there. The product is clearly B. Here you have to learn 2 important things. One is 1,3 dipolar addition. If you have dipolar compound, here N plus and O minus, then you have alkene, which is the electron rich system. Always think of 1,3 dipolar addition because the charge can travel, new 5-member ring is formed. Then the note on heterocyclic ring. Heterocyclic ring will be open on the weak bond. Here NO bond is weak. You can say it's weak or polar. Here it is polar, it can be opened by the hydrogen there. Then the question number 5. The starting metal you have 6-member ring which is in alkene. Then you have alcohol. Other side you have protected ketone which is protected by 1,2-diol there. Both alcohol and the other side protecting ketone is in the syn form. Both are above the plate. Then you are using phosphine and acetic acid. They ask you to find the reagent. But if you see the product is PHCO addition to the reactant. So they ask you to find the reagent here. The reagent is the azo reagent. Whether the substitution in the acid form is important. Whether simple acid is there or simple ester is there or cyanide is there or you have the big bulky 6-member cyclic system. From the reagent you might guess special reagent is involved and its role is important. The answer is D. Let us see how. The starting metal is acid. The reagent is DCC. DCC means dicyclohexyl carbodiamide. The reagent is looking bulky. Its role is just important. It just activates the carbonyl there. It's like AlCl3 with acid. So what really it do is make the acid to donate PHCO. Acetyl cation kind of thing. So it basically like Friedel-Crafts reaction but in the much special and smarter way. So starting metal you have alcohol, you have PHCO, ODCC. Here I avoided the structure for simplicity. So what really happened? it helps the acid to give PHCO. So PHCO and you have alcohol is there. The alcohol attached there to the O. So you have PHCO attachment to the system. So the DCC attachment supply PHCO and ODCC leaves. So here I given for leaving and attachment. Here the big reagents are given but simple chemistry as well as the stereochemistry don't play any role here. So the question is about really checking your stamina and your confidence. Here you have to learn two important things. One is DCC. DCC is the bulky compound. The role is to activate the carbonate there, mostly used in the peptide synthesis. Second thing is DCC help the acid to donate PHCO like Friedel-Crafts reagent. Friedel-Crafts help the acid to give PHCO. That's all from this episode. I hope it was useful. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.